Alright, so welcome back. In the previous video, we created the blend space for our hero character, and now we are going to start building his animation blueprint. Now, an animation blueprint is a special type of blueprint whose sole purpose is to drive the animation of your character. So let's build one first. Let's at least get the asset created, and then we'll jump in and talk a little bit more about how they work inside. So here inside my content browser, I'm gonna right click and we'll go to the animation submenu and you should see animation blueprint. So we'll click on that and immediately it's gonna say, hey, what skeleton should this be associated with? It's also gonna ask you about what parent class this should have. We're not gonna worry about that. We can leave that at its default, but we will associate this with the UE4 mannequin skeleton and click OK. And let's call this you know what? I'm going to do something really different here, and you'll see why shortly. Let's just call this character anim BP. Notice I didn't call it the hero anim BP. That's interesting, right? Well, we'll see why here in just a little bit. Let's go ahead and hit Control S so we save the asset, and then we'll step down inside. Now, the interesting thing is this does not open the blueprint editor. This actually opens Persona, and now Persona has a new tab. Previously, Persona had skeleton and mesh and animation, but now it also has the graph tab. You will only see the graph tab if you are opening an animation blueprint. Now, an animation blueprint is divided into two key parts. You have the event graph and you have the anim graph. Now, at a super high level, here's the difference. The event graph is going to be responsible for gathering information, gathering data from the character, from the world, or from any number of sources, and using that to populate variables. Then you can use the value of those variables to then drive some sort of animation over in the anim graph. Now that's super simplified, high level. In truth, you can do a lot of things inside the event graph, and you can do a whole lot of other things inside the anim graph as well, but we're gonna keep this simple as kind of like your introduction to the system. So the event graph is going to be gathering animation, storing it in variables. And did I say that right? I hope I said event graph just then. So the event graph is gathering all of the information, and then the anim graph is going to be used to drive all of your motions. I can't actually rewind myself. I'd love to be like, did I say that right? And then hit rewind and see if I did, but I can't. So we just have to laugh if I said it wrong. Okay, so over here in the event graph, this is where we're going to begin. And in this video, this is what I want to tackle first. If there's time, then I'll also set up the anim graph, but maybe we'll split that out into another video. So the first thing you're going to see is an event and a node. So you have the event blueprint update animation. So this is an event that is called just about on every single tick. And this is just here to drive your animation. So this is, you're going to always be querying whatever values you start asking in here. Now, underneath this, you have try get pawn owner. Now, this is here because you should pretty much always be using it. And the reason it's here is so that you can do this. You should pretty much do this in all of your animation blueprints. Take your try get pawn owner and do an is valid check on it. Use the question mark version, like so, and connect that up. And that is because technically in the editor, this blueprint has no actual owner. So this is just a best practice. Make sure that you always have this connected. And there you go. So now that we've got that, we need to determine what aspects of our character are important to drive our animation. And this is actually easy for us because earlier, actually in the previous video, we created this blend space called Hero Blend. And if we take a look at the Hero Blend over here in our animation view, it has two axes. It has direction and it has speed. So if we can just get that data, we should have just about everything we need to drive our animation. So let's start by getting the speed, because that's the easy one. If we say try get pawn owner, so this is literally the object that we are animating. If we grab this, we can say get velocity. So now we have the velocity of the character as it moves around. Now, if you don't know this, and you probably do, velocity is a vector. That means it's a line in space. It has a direction and it has a magnitude. That magnitude is defined by the length of the vector. The longer the vector is, the more magnitude it has. So if we take that velocity, since it's a vector, and we get the length Actually, it's not get, just type in the word length. The length of that vector describes the magnitude, which in turn describes the speed. So if you ever get a velocity vector and get the length of that vector, you have the speed of that object, which is pretty cool. So we can take this and we can promote that to a variable. So just right click, choose promote to variable, and we'll name this variable speed. And there we go. So that'll be the first thing that we calculate. Now we need to calculate the direction. And this is a little bit on the tricky side because our character can do something very fancy. He can move in one direction and be rotated in a completely different direction. That's why he can, run backwards or run left and run right. He can be facing one way and moving in another. That means we care about two different rotation values. We care about the rotation of his motion, right? So in terms of his velocity, what is the rotation of that velocity? And then we also care about the direction he's facing. And we're going to take the delta of those two rotations to figure out what his actual direction is. And here's how we do that. Now, a long time ago in a galaxy okay, I won't say that. A long time ago, I mentioned that our character's local x-axis, his local x, is considered forward. And that's a very useful thing to have because when you're doing that, you can use tricks like this. From get velocity, we can use the rotation from x vector node. That is going to assume that the x vector, so the direction of x in that vector, is forward, and it'll give you that rotation. So basically, it's like telling you what the rotation of the velocity is, which is super useful. Next, we need to know what direction the character is actually facing. To make it really clear how we're doing this, I want to jump all the way back to our hero character. So probably like 100 years ago or something, I'm sure that's an approximate value. When we were rotating the character, remember we took our joystick axes, we did some stuff to see how far they were moved, and then we grabbed the controller and then we set the control rotation. And this is where we're setting that rotation value, is inside the controller. So knowing that, we can get that information back from there. So if we grab the pawn owner, we can actually say get control, not set, but get control rotation. So now we have access to what direction he's facing, and we just need to get the delta between these two rotations. So let's do that. Just type in delta, and there you go. So now we have the delta, or the difference between those two rotators. Now, in terms of our game, we have a top-down twin-stick shooter, which is all well and good, but we don't really need yaw, pitch, and roll for that. We only need one of them. And I could ask you which one it is, but I'll just spoil it and tell you right away. All we care about is yaw. That is the rotation along the world z-axis. So what we'll do is we'll take this struct pen for the rotator, right-click, and split it. And now we have access to pitch, yaw, and roll individually. So now let's take yaw, and we will promote that to a variable. We'll call this variable direction. And there we go. So now we are storing speed and we are storing direction. We have access to those 2 points of data that we needed in order to drive our blend space. So now let's go ahead and move over to the anim graph. We've done the job of the event graph, which is collect some data, store it in some variables. Now let's go over to the anim graph, and we're going to use that to drive some animation. Now we can do this in a very, very simple way. So I'm going to do it this way first, and then later we're actually going to remove it and do it in a slightly different way. But bear with me, all right? This is just to kind of prove a point. We're going to go into the asset browser, and we can take our hero blend, which is our blend space. We can drag that right here into the anim graph and connect it up. And take a look. It's got inputs for those two axes, direction and speed. Well, if we go to the My Blueprint tab, here are those two variables that we made over in the event graph. Remember, we had speed and direction. So if we take a look here, there they are. We can drag speed right onto speed. We can take direction and drag it right onto direction. And now if we compile, check it out. Our character goes into his idle pose. And we can test it right here in the anim preview editor. If we increase the speed, he blends into a run. If we change the direction, he'll start changing the direction he's running. Pretty awesome, right? So we know that it's working. So what I want to do is go ahead and stop the video here. So we have gone through the process of building a character blueprint that allows our character to run around. It's not perfect yet because we have other animations that we want to work in, specifically the death animations. So we're going to do that in the next video, but for now, let's go ahead and wrap things up here. You're able to test this out right here inside the persona preview window by changing the speed of the character and changing its direction. So that'll wrap things up for this video. Thank you so much for joining us.